Okay, hello everyone and welcome back. I hope you all had a good break. Y'all, today we're going to look at quadratic functions in factored form. And we've looked at them before. Let's look at them a little deeper now. Learn a couple things about them. Oh, April 6th and 7th. Gotta change that. All right, guys, today's objective is to graph a quadratic function in factored form. Guys, if we take a look at, this is factored form right here. We've seen it before. Guys, this is the same quadratic as these two down here. This first one is standard form, and this one is vertex form. It's the same quadratic. It's just represented three different ways. Today's essential question: how do we find the x-intercepts and the vertex of a quadratic in factored form? You need to find the vertex in order to graph it. How do we get that hk? All right, again, we've seen a couple forms of quadratics, standard and vertex. In this lesson, we'll see there's some advantages to factored form. All right, let's look at three graphs again. These are three the same quadratic. They're just represented three different ways algebraically. Graphically, obviously, they look the same. All right, this vertex form, y plus 4, just think of the 4 on the other side, minus 4 on the other side, okay? And again, just to prove that these three algebraically are the same, you can multiply them out, and you end up with the same standard form for each of the three. Guys, of the three forms, each one easily reveals some key aspect of the function. All right, you need to know this, and you kind of already do know it. Guys, vertex form easily shows you the vertex, the hk. All right, 3, -4. It's pretty easy to see here in vertex form. Guys, standard form easily shows you the y-intercept, +5. Right up here, 0, -5. All right, and factored form readily, easily shows you the x-intercepts. All right, x minus 1, x minus 5. That means it goes through at 1, 0, and 5, 0. All right, it easily shows you the x-intercepts, and that's important to know. All right, which is what this is saying right here. The graph of an equation in factored form, it's a parabola that intersects the x-axis at R1 and R2. All right, sometimes we call this R and S. All right, so as an example, when it says x plus 2, x minus 3, all right, it goes through at -2 and 3. All right, I put this in Desmos, and that's what I got. Now, if you go to Desmos here, we can do that. Again, you notice the +2 and the -3. It goes through at -2 plus 3. I'll show you why that is here in a minute. But you can see that the R, if I just change the R, now one of them goes through at 3. Or I'm sorry, at -3. All right, and the other one still goes through at 1. All right, when R is -3, remember that one of these up here then is going to say x plus 3. All right, just to show you that, you can play with that. There's a link to it in Schoology. All right. Again, the x-intercepts are readily available. They're easily revealed in factored form. All right, that's the point there. All right, now algebraically, why does that happen? It's something called the zero product property. It's a relatively simple concept, but you need to understand it. Again, if two numbers multiplied together equals 0, then one of those two numbers have to be 0. So once you get it in factored form, all right, if you set it equal to 0 to find out where y is 0, one or either of those two factors have to be equal to 0. Okay? So at the x-axis, x equals r or x equals s. All right? And that's basically what this is saying right here. Okay? And you can take a look at that, you guys. I also want to talk about the value of a. All right, what happens when we change the value of a? If you notice, each of these have the same factors. These are all different quadratics. They all say x plus 4, x minus 2. The only thing we're changing is the a in front. All right? The intercepts all stay the same, but the vertex changes. The intercepts all stay the same. If we put them on the same graph, you can kind of see that. The intercepts are all the same. We're just changing a, all right? So the x-intercepts stay the same in factored form when you change the a. All right, changing the value of a does not change the x-intercepts. All right, here, let's take a look at that. I'm going to change the value of a. Let's get rid of that one. Watch the blue. You see how it still goes through -3 and 1? No matter how I change it, it still goes through -3 and 1. Okay, at that point, it's just 0. You see that? All right, just to show you. All right, guys, a very important concept. The axis of symmetry is always located halfway between the two x-intercepts. All right, so how do you find the axis of symmetry? Just take the r plus s and divide it by 2. It's always halfway in between the two x-intercepts, always. Okay? And remember, the axis of symmetry is the same as h. All right, so because the axis of symmetry also goes through the vertex, once we find what h is, all right, we can plug it in and find what k is. Just plug it back into the original equation. All right, use the factored form already there. Just plug h in there. Okay? All right, as an example, what's the vertex of this quadratic right here? It's upside down, negative. All right, x minus 1, x minus 5. All right, so the h and the k, the two intercepts are 1 and 5. Well, what's halfway in between 1 and 5? It's 3, of course. All right, so k is 3. So just plug it back in right here where x is in the original equation. 3 minus 1 and 3 minus 5. All right, you end up with 4. Right, 2 negatives make a positive. So the vertex is at 3, 4. Okay? All right, guys, that's it. I'm running out of time here. Fill out today's notes assignment and complete the summary. All right, they're in the green folder. Guys, today's 4 vocabulary questions. Since we don't really have a new vocabulary today except for the zero product property, there's 4 questions. And what is true about changing the value of a? All right, we looked at that. Then I need you to select one of the quadratics in factored form. All right, you need to know that. And guys, each quadratic form, remember, there's something that is most easily revealed, all right, from the form that it's in. You need to match that. All right, that's it. Thanks.